What are the parts of a Boolean of a if statement?
Boolean expression and expression.
So Boolean expression, what to do if it's true, what to do if it's false. And a Boolean isn't that an if statement?
Well, it doesn't have to have the false expression, does it?
Doesn't have to, but I mean, the if statement does support that. But if you add just these two, I'm
the else statement that supports that.
well, but the else statement that you can't just have an else.
Yeah, you do.
Yeah, else's don't exist standalone. They're part of the if. So if you didn't give me the else, I'll probably give you a 5% on the quiz. I was mostly looking for whether you could give me some sort of structure. So if you were writing this kind of you could have actually written it like this, and I'd be okay with that. Pseudocode, since I was asking you to invent some classes anyways. Specifically Boolean expression. But if you were to write this as some code, which is kind of what I was maybe expecting, you'd say something like public class if statement, probably in caps, but whatever. And then this guy is going to have a maybe a Boolean expression called test expr. Then he'll have a expression, true expression, and expression, false expression. And then you probably have a constructor for this. That's going to take in a Boolean expression TE. Oh, it's going to have to say Boolean expression test, expression TR, expression FA. And you would set this dot test expr equal to test. This dot true expr is equal to tr. This dot false expr is equal to fa. Something along those lines. Oh, thank you. All right, so something along these lines would have been kind of what I was looking for. Make sense? Aren't those the pieces of an if statement? All right, kind of an interesting thing that happened yesterday related to this, well, related to programming in general, is in the 200 class, we're messing around with this language called Blockly, which I think I showed you guys in here a little bit. It's a graphical programming language. So you write all your code like this. Huh?
That looks like it would suck.
It actually is quite fun.
Oh, it sucks.
Dude, you're not good at this. And you're not good at that.
Look at all that.
But what it ultimately does is it generates JavaScript or Python or Dart. So you actually create things in terms of blocks. So, if you want to create a variable, you say variable.
So this is for people that don't know what they're doing.
Well, no, it's actually a good way to learn logic without syntax. So, I'm gonna set, let's just rename, call this guy num, set num equal to 5. that's int num equals 5 is the equivalent in Java. So it's not hard to work with, right? Just kind of working with puzzle pieces and stuff. But what's interesting is in class yesterday, we wrote this like play guessing game thing on kind of leading up to what they were doing with building formulas and processing math formulas, kind of like what we've been doing in here, but the Blockly way of doing it. So, we had a thing where we just generated a random number between 1 and 100, and then, they kept guessing until they got it right. It would say too low, too high, winner, that kind of stuff. So,
What's the loser part?
Well, we gave them an infinite number of things. We just counted how many they did. But originally we had it at, 1 through 10, I think. And the first time it took us like 4 guesses or something. And then somebody in the class said, well, could you even do this in 3? And I said, well, of course, I'm the programmer. I wrote it. Right? So I did it the first time. I did it in 2 guesses. And then I said, you know what? Just to show off, I'll do it in the first try. 4 times in a row. 4 times in a row, I did it on the first try. Every single time I called it. And then I got a little cocky because I switched this up to 1 to 100 and say, look, I'm going to do it again. That worked less well. Okay, but here, I'll do it for you. This is Christian worldview because I just did a little prayer. Oh. Nailed it. All right. So kind of a cool thing, right? Yeah, the last thing I printed out was how many guesses it took. Yeah, Blockly's really neat. I like it, but I just thought I wanted to savant mode in class. But it was really funny, as I was joking when I said it, and then I did it 4 times in a row, and to the point where we actually thought we had introduced a bug. I had such a high success rate. All right.
Did you try to do that last semester or 2 semesters ago with Flappy Bird, and that didn't go very well?
Well, that's different. I didn't write that.
You were talking about writing.
Well, yeah, if I had written it, I would have been able to do it, beat Flappy Birds in 1 move. It's called an Easter egg. I know I mentioned this in one of my other classes yesterday, but there's a really cool book that I'm plugging. First of all, are all of you guys on Slack now? There's extra credit opportunities on Slack, so if you're not on Slack, you should get on Slack. First extra credit opportunity from this point forward is actually this afternoon. If you want to come and attend the senior seminar presentations, starts at 2:35 until just before 4, although... Do you know, did Ali actually find a replacement? You saw the email that he sent out? Oh, no, you wouldn't. You wouldn't have because you're already presenting today. Ali's supposed to present today, but he has a conflict. So it's possible we'll only have 2 presenters today instead of 3, so it'll actually go a little shorter, but plan on 3, so it's about 2:35 until...
3:50.
Yeah.
We were making good time on Tuesday until I had a 40-minute presentation.
Yeah, but I mean, realistically, that was probably the best of the 3. At least it had all those details, right? The other 2 were like 10, 15-minute presentations. They're supposed to go 30 minutes.
Oh, they are.
Supposed to go 30 minutes. So it's supposed to be...
25 minutes for the presentation, 5 for Q&A.
Yep. Okay, so, the punchline is plan on being here roughly an hour and a half for your extra credit. But attend the senior seminar presentations. This is their last hurrah before we turn them out loose into the real world. You get to see them present stuff. In fact, you're dressed up going today, I assume.
Yes.
So Christian's presenting today on his database thing he worked on. So is it going to be good or?
Did Professor Wall actually email you?
Yeah, he did.
Tuesday? Okay.
He did.
I'm going to try to.
He gave me the sob story. The whole. I was pretty aware what was going on.
I'm going to try to make it about what I did to counter what ended up happening.
That's fine.
It's going to be what I learned and how I tried.
Yeah,
to
nothing wrong with that.
that.
Okay, so you can come and cheer him on and see what goes. Heckle him, make him sweat it out.
There's going to be some really corny humor in there, so I apologize.
Like Locklear level corny humor.
There is a comic, but it's not Dilbert.
Oh, do you tell the audience to laugh?
No.
See, I just never understood that. But I mean, I guess I'm naturally hilarious. See, look, I didn't. It reminds me of an old Seinfeld episode where they were talking to, like, Jerry couldn't help but be funny, and George kept thinking that Jerry was showing him up at this like double date they were on or something like that. Yeah, but in any case, I encourage you to show up to that. I'll give you extra credit in here. If you're in more than one of my classes, you get extra credit in multiple classes.
Oh, yeah. Do I get extra credit because I have to be there
Yeah.
anyway?
Hey, you get extra credit in here.
Yeah.
For being there. Yeah.
Okay.
You're there. You're there. Just because you have to be there is a whole different story. I mean, you don't.
You get extra credit for presenting.
You deserve it, right?
I think so.
Yeah. I would say I'm a fairly fair guy. I'm usually.
No, that's fair.
No, it's Pebbles. That's why we named him Pebbles. All right, but if you're not on Slack yet, go ahead and get on Slack. We had people asking questions about the homework assignment last night. He was begging me for a solution, and
We
I
had already, except like 2 small things.
wasn't it way easier than you thought it was going to be?
Well, we had it
No,
done,
we
but
pretty much had it.
Yeah,
we just forgot to set something equal to null and return. Well, we did return it at the end.
excuses. So anyways, I helped him out, and then I kind of posted on there that he had the secret, and then old Alex was trying to. He tried to make a move, and I had him begging me for help. It was highly entertaining. But in any case, I mean, weren't you getting pretty
And then Chris-
until it got near bedtime? Weren't you getting pretty quick responses from me?
Well, there was one break about 40 minutes.
Oh, that's when I was getting my trailer hitch put on my car.
No,
Yeah.
other than that,
Yeah. So
So is it on and ready to go?
it is.
Have you tested it?
Well, not yet. But he had me stand on it because he said that the tongue weight of the boat is about 350 pounds or so. So that was a reasonable test. Me standing on it. What was I talking about? Oh, homework assignment. All right, so here's our code that we were working on, and what I asked you to do is, well, last time we built all these objects, right? So we have this. Where's our statement? Here's our var def statement. So var def statement keeps track of a variable expression and a math expression. Those are the 2 pieces of a var def statement. So variable name equals value. In our case, our value is always a math expression, and our variable name is what? A variable expression is just a string. So all we need to build one of these dudes is a string, right? All right, then what's a math expression? A math expression is an expression of some kind. So either another math expression or a variable expression, one of those 2 dudes, right? Followed by another expression, math expression followed by, an expression followed by an op expression followed by a expression. Those are the 3 pieces of our math expression. Okay, what's an op expression? It's a single char. That is the op. Okay, we don't even have a way of getting that guy yet because we're not processing our expressions at this point. We're kind of building our syntax tree. Okay, and one of the things we want to see here is as we were drawing our syntax trees out over the last week and a half or so, they keep looking complex, right? Syntax trees seem like they're very difficult, and we think about them. We're like, okay, well, how are we going to build that? How, it seems so much more of a complex data structure than like binary trees. Would you agree with that? Okay. How many of you felt after you figured out what was being asked, the homework was pretty easy last night? How many of you would believe that you just built a syntax tree? It's done. Data structure. You have the full data structure for a syntax tree already written.
We're missing a bunch of methods.
What do you mean you're missing a bunch of methods? You have that structure. Root node is a var def statement. Hanging off that is 2 child nodes. var expression, the math expression. Hanging off that math expression is some child nodes. At the very least 3. A var expression, an op expression, and a math expression. But they might be a lot deeper than that because you might have a math expression over here which has 3 things hanging off of that. You might have a math expression over here which has 3 things hanging off of that. so on and so forth. As you got the spill-through effect, if we were to print that out, you have a syntax tree already built. Built it without even knowing it. Make sense? All right, so that incredibly complex data structure that you thought was going to be a nightmare to build. It sounds like something you would say because you're foreign stuff.
I don't even.
I like to start every class off with offending everybody. Yeah, it's recorded. I like to provide the prosecutor's evidence to everything. You broken?
Oh yeah, my shoulder is on fire today.
Really? Did you take pills?
No, I don't have it. Not any that don't put me to sleep.
All right. It's probably from when you were trying to get that one thing loose.
I think so. Yeah.
Okay. So in any case, we've built the syntax trees. Now let's go and do what the homework assignment asked you to do. Where am I at? In parser? Okay. So what we're going to do is we're going to, just out of curiosity, did we build a generic statement? No, we didn't. We just have something that's a var def, or a var def statement. So I'm going to modify parse statement. This guy's now going to return a var def statement. We have one statement in our language, right? Called a var def statement. If we expand that a little bit, we're going to allow for this guy to return things that maybe are generic statements, where statements might fall into a couple different categories. But right now we support one kind of statement. That's a var def statement. So whenever we call parse statement, what we're actually expecting it to ultimately boil down to is a var def statement, which I just explained to you is actually a syntax tree. Okay, so this guy is always going to return a var def statement. Now, quickly, what do we need to define a var def statement? We need both a var expression and a math expression. We need two pieces of information before we can build a var def statement. Okay? It just so happens, right off the bat, we have that string for our var expression. So I'm going to go ahead and right here, we're going to say var expression, the VE is equal to a new var expression, var name. Last time we proved that we could get it. I love this reaction.
Do you have to return it or no?
Eventually.
No, I mean, like, couldn't you just leave a void and not return it, but create it?
Oh, for your homework? I don't care.
No.
Yeah, I'm just writing the whole thing out. I mean, he's asking, do you have to return this value here? I don't care. You have it to return if you want it. You're going to build it anyways. All right.
For that var expression, could you make that global variable? Like a global var expression?
I'm going to say no, because you actually would run into problems with that, because he tried to do that. And as you have more complex statements, what you end up having is if you have a single global variable up top,
I mean, like
you have.
absolutely.
Oh yeah. Well, see, now it only works for individual ones then.
Yeah.
It only works for very specific expressions, because if you have, who are we getting var expressions from? We're ultimately getting these guys from calling parse expression, correct? Ultimately that's where we're going to get it from. We happen to know in this case we have a simple var expression that we know we're going to have that variable name. That's part of the statement. Okay? But as you have parse expression being called multiple times, you might have math expressions inside of math expressions inside of math expressions, all fighting over this single global var expression. That makes sense? Overwriting it, depending on which level of recursion you're currently in, becomes problematic. Okay, you want to have everything self-contained. Christian had a similar issue. All right, so we know right off the bat we just parse the variable name. That's the left-hand side of our assignment operator in our var def statement. And what will we do with that variable name? We're going to build ourselves a nice little var expression. Done. Then we burn past the equal sign, unimportant for our syntax tree. Then we call parse math expression. Now, we're going to say, what did I call it? Math expression? Math expression, ME, what's called the ME, is equal to whatever's returned by parse math expression. What we're going to do now is we're going to have to modify parse math expression so that this guy ultimately returns a math expression. So instead of this guy returning a void, he's going to return a math expression. Makes pretty good sense. How do you get a math expression? You call a parse math expression. He's the guy who builds math expressions for us. Fair enough. Then we burn past our semicolon here at the very end, and ultimately, we're going to return a new var def statement with the VE and the ME. The two pieces that we acquired up here that go into making a var def statement. Make sense? That's all you need. 3 lines of code in var def statement. 1, 2, 3, and just update the return type. If you chose not to update the return type, as Curcio did, then you really only needed the 3. Just store the var def expression in a variable and say, I got it if you ever need it. Okay? So let's go to math expression. So here's our parse math expression. This guy now takes, he's going to ultimately return a math expression. What does a math expression need to work? He needs an expression, and an op expression. Make sense? Now let me just... We could question whether it's appropriate for us to make an op expression an expression. You could debate that from a language building perspective. We just had everything inherit from expression, which is fine. It's not the end of the world. Where an expression is just an empty husk here. I might say that you might choose to not make these guys expressions. It really would have no difference on your ultimate solution here since we specified op expression. Okay, but we might say that an op expression is really just a wrapper for a char so that we can handle chars as objects. Okay, so what I just did there is really optional. It wouldn't have made a difference in your solution at all. I'm just doing this more for the long term, where we're going with this. Because in this particular case, the left and the right for a math expression really can't be op expressions, right? We can't have plus, plus, plus. That's not a valid math expression. Correct? That doesn't, well, maybe in your world that might be valid, given the crap you wrote on this piece of paper. You doing lunch today? Oh, because I wanted to be able to yell at you, and now I'm disappointed, actually.
One of the reasons I'm not on lunch.
Really?
I went to the dealership. They were parts from my car.
What kind of dealership, Pebbles?
What kind of dealership do you go to?
I don't know what kind of dealerships you go to.
ISIS one?
That's recorded. I didn't say that. I'm not touching that one.
If the NSA is listening, he goes to Concordia.
That was actually in a book I recently read. Oh, I was getting ready to tell you about a book a few minutes ago, wasn't I?
Yeah.
Oh, well, let me tell you 2 books, and then we'll keep writing this. The book I just read, it was just that brought this idea up. There was a whole conspiracy thing. The book is it's by name Ted Decker is the author, and it's kind of it's a whole book series. It's kind of Indiana Jones. Think Indiana Jones, but the Indiana Jones character split across 2 characters. One of them is this archaeologist called Nina Weil. The other one is Eddie Chase. He's the bodyguard. He's the muscle. He's the action guy, and then she's the brains. Where Indiana Jones was all one person. So really, really good. I think the original book is called Hunt for Atlantis. So she keeps finding, interesting, historical things. She finds Atlantis and the Tomb of Hercules, and El Dorado is another one of the books. But in any case, there was the thing that reminded me of that is there was this one thing where a former president who had, gotten ejected from office for illegal stuff and things like that, was trying to blackmail them.
Bill Clinton?
No, it was made up guy from the book. And while they were on the phone, the guy thought he was, the president thought he had won. And then A.D. Chase just started rattling off, ISIS, terrorist, bomb, all these just buzzwords that he knows the CIA is listening for to record, to signal out that cell phone call. So then the president gets arrested a second time. It was funny. That's what reminded me of that. But the book I was going to tell you about is called Ready Player One. So in any case, kind of the premise of this book is... So it's set in probably the kind of the near-ish future. So like these MMO video games, World of Warcraft, EverQuest, things like that. Let's take that to the next level of evolution where now it's not just a game. People have their entire lives in the virtual world. Okay, so the virtual world in this is called the Oasis. And people at their houses in real life have like haptic chairs and stuff like that. They just basically plug into and they live most of their lives inside the virtual world. Well, in any case, the creator of the Oasis from the book, he dies. He got old, died, blah, blah, blah. Well, in his will, instead of leaving his zillions of dollars that he made from, basically reinventing humanity, instead of leaving it to like his company or a relative or something like that, he left it in the form of an Easter egg inside of the game. So there was kind of this like epic quest that he created in the game that really just at the starting point was a little riddle that sent you on the lines for this epic quest. And whichever person in the Oasis finished the quest line first gets the fortune. So now what you have is it's been like going on for like 5 or 6 years now before even the first part of the quest was figured out. So it's a really complex thing. And schools are teaching courses on this guy's background for people to try to like learn about the, from the 1980s when this guy kind of grew up with Pac-Man and stuff like that, trying to figure out what the first clue might mean. And you have, these individuals who are trying to solve it as single persons. Then you have groups, kind of clans that are come together to try to help each other to solve it. And then you have the corporations, the evil corporations that what they do is they actually hire players, pay them a salary with the hopes that eventually, because of their resources, their financial resources they have, they'll eventually win the zillions and they'll control the Oasis and all this stuff. So just really fascinating as the kind of the book unfolds and very computer sciencey. I'd highly recommend it. And I just found out the other day that it's going to be made into a movie and Steven Spielberg's going to produce it. So, are going to direct it rather. So, I think he's director and producer. But whatever. He's typically when he gets involved in a movie, it's probably not complete crap. Right. So, kind of an interesting thing. So, I'd recommend the book. I've been listening to it. I'm about probably 85% through it now. And I listen to it on audible.com. And the Will Wheaton is the reader. So we remember back from Star Trek, but he also was in Big Bang Theory pretty often. So it's pretty interesting when he reads it. Okay. Oh, all right. So we're back here. We're inside of parse math expression, right? What do we need for a math expression? We need a left operand, a right operand, and a op expression. Well, let's go back into parser. This is where we're trying to get our left operand, correct? So we read something in. In fact, what I'm going to do here is right at the top of math expression, I'm going to give myself my 3 variables. Okay, so I'm going to say I need an expression called left operand. I need an expression called right operand. And I need a op expression called the op. I'll call it the op expression, as long as we're being verbose. So I'm going to need to fill in these 3 variables somewhere inside of this math expression. So at the very end, all the way down here, I can actually build my math expression and return it. Okay? So if the variable name was length, what does that mean? That means that we had a math expression as our left expression. So we're going to burn through it, and we're going to say this dot left operand, not this dot, sorry. Left operand is equal to that. That's a local variable, not something that's owned by the object. Otherwise, it must have been a variable name. So we'll actually say left operand is equal to a new var expression, var name. So left operand in this particular instance of parse math expression will be one of two things. It'll either be a math expression, if we ran into an opening parenthesis first, or it'll be a var expression. Okay? So we're guaranteed after these two lines to have filled in left operand. So after this if statement, left operand definitely has a value. Now just so Java doesn't get pissed at us, we're going to go ahead and default left operand to null up here. So we're explicitly giving a value so that when we return it, we can, Java's convinced that we did what we meant to do. So we'll give all those guys just initial values of null. Now after this if else, we're guaranteed that left operand has a value. But notice here that inside the if, this guy could get way more complex, right? Left operand is actually equal to whatever's returned by another call to parse math expression. Make sense? Otherwise, if we're kind of at the end of the line for our left operand, we just create our var expression and we're done. Then we read in our op. Okay, right now our op is coming in as well, it comes in as a string, it looks like, right? Okay, so what we're going to say is what do I call it? The op expression. The op expression, did I use capital P? Nope, we're good. Is equal to a new op expression, and we'll pass it op.char at 0. It's good enough. Similarly, you could have updated op expression to take in a string instead of a char, or whatever made you happy. Okay. Yeah. Okay. Then, just like we did up here, we're going to read in a variable name. If it's equal to 0, we're going to say right operand is equal to whatever's returned by our parse math expression. Otherwise, we'll say right operand is equal to new var expression var name. Finally, after all is said and done, what are we doing? We're going to return a new math expression, passing it left operand, right operand, and the op expression, which is what the constructor for this guy took. Here's our math expression, left, right, op. So now parse math expression returns a math expression. Parse var def statement returns a var def statement. All the way up here, when we first call that guy, right here, when we call parse statement, what we can do is, this is in our parser. If you want to have a single global guy here, we can say private var def statement. Let's call this guy the syntax tree. After we call parse statement, we'll say this dot the syntax tree is equal to whatever is returned by that, and That's that. Make sense? So that's the solution to the homework. Just build objects. So if we're looking at our examples here, like this guy. Isn't it funny? I actually showed you this slide. Isn't this the exact solution? What was all the confusion then? You got this right, Fair?
Yeah, I nailed it.
Did you ask any questions?
Well, actually,
Or did you just not do it?
me and Austin and Josh actually worked on it.
Who?
Austin and Josh, I mean,
Oh, they helped you? Did you get it right?
some of it. They did make
Did he learn anything?
Well, I talked to you after he left, so
So
you didn't
no.
have a chance.
So no. He didn't get the gold. He got like a unpolished silver at best. Makes sense.
It's more than I would have done by myself.
It's better than the bronze.
Shiny pebbles.
shiny pebbles is what you got. All right. So, just like we this guy breaks down, we have our syntax tree at the top. That's our var def statement. On the left, we have a var expression. On the right, we have a math expression. In this particular case, we have another math expression. So the left operand here is a math expression. The right operand is a var expression. And then we have our op expression in the middle. So our math expression goes one deeper. We would have a var expression for the left operand for that version. So we had a parse math expression and we had another parse math expression. Two separate calls to parse math expression. The first call returned this dude. The second call returned this dude. Make sense? All right. So now, what if we want to have our statement have the ability to display itself, proving that it did its stuff? All right, go ahead.
Should you initialize syntax tree as null
Oh, we can.
in the constructor?
We can.
That hard work you did last night put on the hitch.
I know. I drank a lot of iced tea during that.
I know. The whole 45 minutes.
Seriously. Well, you were working before that. I was in my massage chair before that.
Yeah.
Those things are phenomenal.
Well, didn't I say yesterday that I was going to get my massage chair while he was working? For any of you you were there, weren't you? You in the networking class? Who's in the networking class? I said that, didn't I? The end of class? Yeah.
It's like
I didn't do anything I didn't say I was going to do.
You didn't help me lift it out of the box.
I moved the box into the garage. That was a lot of work.
With the massage chair?
Huh?
With the massage chair?
No, it's hitch first car.
Well, then I almost hurt my back because he asked me to hand him the scissors. It was sitting right next to him.
It's hilarious. Watching struggle.
Well, that's very difficult to control this much weight when you have a broken back down to that low on the floor. Now, if you need me to reach something that's like 7.5 or 8 feet up in the air, that's going to require you to like get a whole ladder.
I was about to say that.
That's what I'm built for. That's what I'm built for. I think that's one of the main reasons my wife married me, is to get things off of high shelves.
Well, hey, my brother threw out his back picking up deodorant off the floor.
It's like stupid stuff like that, right? Although, you know, he's your brother's pretty built though. You guys both are football-y, lifter type folk.
Well, he's in better shape than I am.
All right. Well, I'm like mostly fluff now. Once upon a time when I used to play a lot of tennis, I was fairly ripped. But I mean, I think there's still muscle. You don't believe me? You know, I used to play professional tennis just about.
No, I know, but I don't know about the rip.
I was.
Picture
I actually was in really good shape. I have a picture somewhere. I was in really good. Once upon a time, I was actually in really great shape.
How old were you when this was going on?
I played tennis at the University of Illinois when I was 19, and
You actually played in college?
I played at Division I school that was the #1 school in the country. I played #1 on the team.
Oh, wow.
I was a really good tennis player. My dad used to play professional tennis. My brother and I had been playing since we were old enough to hold a racket. So I played tennis at 6'5", 230 pounds, and when you're playing 7 or 8 hours of tennis a day, you don't have much fat. But I was always a huge eater. But then I broke my back, and now you take away all that exercise, I ballooned up pretty quick.
You're still a huge eater.
Yeah. Well, then you had the depression of now you can't do something you used to do.
More.
Yeah, just eat even more. So.
You just gotta find something to take with the swim.
Yeah, well, I mean, the punchline is I'm mostly fluff now. But once upon a time, leaning over and picking stuff off the floor wasn't a big deal. But when I broke my back playing tennis. So that's why I stopped playing tennis. I was serving in finals of a tournament, and hitting a kick serve, my 4th and 5th lumbar collapsed forward. So the back of my head was laying on my heels.
Any bones sticking out?
No, but it was in that category. It was totally awesome. My mom has a video somewhere. I should show it in class.
Sounds awesome.
But I mean, it's going to be like on like Betamax tape. Yeah.
I'm sure there's a death or something.
Yeah. Well, yeah, but the question is how has the tape, where she stored the tape. Yeah, when I was 19 years old, that was some time ago. There's some years in there.
I had a PhD.
Just barely. just barely. But yeah, so in any case, so I broke my back, and now I'm only about 6'3.5", 6'4". So I lost some bone that was crushed. They couldn't. I went to Mayo Clinic. They were going to do a fusion, but I have a couple of other back problems. I have something called spinal stenosis, which is just a narrowing of the spinal column. So working in the lower lumbar there is kind of dangerous. They might nick the spinal cord. And it was a type thing where like, we can fuse it, but you're really not going to be in any less pain because of where it's at. You have your entire body weight above it, and you're going to be less mobile. So it was kind of the type thing where fusing it is only going to give you stability. It's not going to give you much of any additional relief. So we just didn't fuse it. I suffered for 10 years, and finally all the nerves just died. So my back hurts every day, but it's pretty tolerable now. Not a big deal. Unless somebody has me pick up scissors off the floor.
They're right next to me too in the end, which I kind of felt bad after.
No, I didn't. I was fine. I didn't hurt myself. I kind of have invented techniques for controlling my amount of weight down to the ground.
We tested his hitch with him too. Works. It'll hold the weight of his boat just fine, I think.
Yeah, just had me stand on it. It's like, yeah, boat, Lippmann, about the same weight. What was I doing? Oh, what if we want to print our syntax tree, right? All right. So what we want to do here is to kind of prove that we built an accurate syntax tree, we want to teach our var statements, var def statements, how to print themselves. So what we're going to do is we're here in var def statement. Now, remind me, if I want to be able to say, here, we're gonna come out here real quick. We'll go out to driver. Get rid of this jazz. We have p.parse. Let's go ahead and give ourselves a getter for our var def statement. So I'm just going to do source, generate getters and setters. And we want our syntax tree, and we just want to be able to get that. That way we can get it outside in driver. All right, so we have that now. So now here in driver, I can go ahead and say var def.
Don't you get that though? Can't you set it equal to something because you return it?
I don't return it from parse.
Oh, okay.
Parse doesn't return it. Parse statement returns it. We could certainly have parse return it if we wanted to. In fact, it may even make sense, but so var def statement is, I need to have this on a different line. VDS is equal to p dot get the syntax tree. And then I'm going to say system.out.println VDS What should the output of this program here be, Pebbles? That line right there, what should the output be? You don't have to know about it. Everything you need to answer that question is in these two lines.
Syntax. I'm gonna bring out get the syntax. Apple.
Rock, goat, pumpkin. I can say random words too.
All right, what's it going to be?
It'll be the memory address.
Okay, it's going to be a memory address of a var-def statement. So there's our memory address of our var-def statement.
I knew that.
I can't believe that. Why didn't you answer with that?
It was funny the way I did this.
No.
Apple is more.
You're only cheating yourself, dude. Okay. Now, I'd like this guy to print out something other than the memory address. What do I need to do inside a var-def statement? If I want this to print out something, since you know all this stuff, if I want this to print out something other than the memory address, what do I have to do inside a var-def statement?
Edit the VDS.
Edit the VDS? Okay, that's what I asked. What do I have to do inside here? What do I have to add in here in order for it to print out something other than a memory address?
Are we talking about a different? Are we talking about add like words? Or are we talking about the whole memory address? You want to print out something else?
I want to print out something other than the default. The default, as we've seen, is a memory address, right? What do I need to add to var-def statements so that it prints out something that we have control over, as opposed to what it inherited from object?
Need a separate display.
Okay, but a separate display method's not going to allow me to print it like this. Separate display method will require me to say VDS.display.
Right.
So I want to be able to print it like this. Got nothing?
In the past.
Levi? Yeah, but what do I need to put? What do I need to put in var-def statement in order for this line right here? I'm not going to change this line at all. For that line to print out something other than a memory address. So I mean, for right now, I want that line I have highlighted to print out hello world.
It's not VDS.
Who's got me here?
Is it a two-string method?
Two-string method. All right, so we come in here. We're going to say public string two-string, which is a method we inherited from our parent, right? Method we inherited from our parent. And we're just going to have this guy return, in this case, hello world. Which has nothing to do with our syntax tree, but it will prove that this line now performs differently. Okay? So there's all our work for our syntax tree, and in the end, it just prints out hello world instead of a memory address. Who prints out a memory address? The two-string method of our parent. And inside of our def statement, who's this guy's parent, Pebbles? There's something invisible right there. Something invisible in that, what I have highlighted there.
Parser.
All right, don't guess. var def statement. If I come in here, I'm going to prove it. I'm going to say we're going to return this concatenated with, well, we'll just put the space here. Concatenated with super dot toString. So this is my parent's toString method. Okay, we'll go ahead and run this, and we'll see now we get hello world followed by the result of our parent's toString method, which is that memory address. Who is my parent here? My parent's identity is hidden in invisible ink right there. We've talked about this quite a bit.
Extend something.
Raise your hand if you know the answer to this. Have the answer? Oh, it is extend something. I'm going to give you points for that. Okay. We do have extend something.
Yeah,
So
I mean, I know that's the invisible part, but you just don't know.
what comes after extends? Oh, you got me?
No, I was gonna guess.
All right. Well, I'm going to take a guess, but try to make it an intelligent one. I have faith.
Expression. Not expression. Part of statement.
All right, hold on. Stop. For any object we've ever created, this invisible ink is there. The people who made Java, did they know about our var def statement or our expression or our math expression? Those things didn't exist back then, right? It has to be something that existed way back at the beginning. Main's a method. We extend objects. What objects should be here? By the way, those who are laughing know that I just said the answer. So go with it.
Oh wait, you're asking me at the
I literally just said the answer. You just have to repeat what I said.
object.
Object. Okay, so what's right here? Is that tonight? Celebrity Jeopardy? Days of the week that end in day. Okay, so this guy extends object. So object is our parent for any class that doesn't have an explicit parent. So for instance, inside of math expression, this guy's parent is who? Who's this guy's parent? Expression. Now I'm going to go into expression. Who's expression's parent? Invisible ink. Got invisible ink. Who's the parent of anything with invisible ink? Object. Okay, so we have 3 levels here. We have object, expression, math expression in this inheritance model. In our inheritance model here with var def statement, we have object followed by var def statement. The only thing above var def statement is object. So var def statement's super is toString. Or var statement super is object whose toString returns the memory address. And that's why when we print out here, we get our hello world, the thing we wrote right here, but we concatenated onto that whatever the toString method of our parent returns, which was the memory address. Make sense? So this is how we make our objects compatible with the println method, by giving them a toString method. We could certainly give it a display method that ultimately accomplishes something very similar, but we might as well support the way that things are printed to the screen. System.out.println's how we print crap to the screen. Why not make our objects compatible with that? Make sense? All right, so we're going to write a toString method here. But instead of just printing out hello world, we'd like it to actually print out a representation of our statement, of our parsed statement. And what I want this guy to print out is that. We took this as input, went through all the work to split it into a syntax tree. Now I want our toString to print out the original without just printing out the string that we stored above. I want to rebuild this from our syntax tree. Make sense?
Considering we don't store the parentheses or the equal sign, we just burn past them.
Mm-hmm.
We can put those back.
Would you say that every var def expression has a var def statement has an equal sign in it? Is this always there in every var def statement? Is this always there in every var def statement?
So you can just
Couldn't we just throw it back in?
So would we just print out the var expression and then equal sign and the math expression?
Huh?
Would we print out the var expression? Would we bring that in?
Yeah, we have our var expression. So you want to display that first, right? Okay. Well, what's our var? So that means inside of var expression, we need to give a toString.
What is the string already?
Well, it is a string already, but we don't have a way of accessing it. So why don't we just use everybody's toString? Okay. Well, we could use everybody's toString. Yeah, I like using everybody's toString. I think it. Yeah, we're gonna do that.
Could you go over what toString is again? Like,
No, I've already covered it today. If you're too stupid to follow it, I'll cover it. So let's go back, way back in the java.sun.com. Go to the documentation. So we're going to go look at the Java documentation. We're going to go all the way to the top level, and we will look at object. And in object, we have a method that's provided for us called toString. So this is the top level dude in the entire language, right? All objects come from this guy. Way down here, we see we have a method here called toString that guarantees that every single object in the entire language, okay, any object we ever create in Java is guaranteed to have a toString, right? Therefore, the generic version of this guy will return a string that is the memory addressy looking version of that. Okay. Now we want to go and look at the println thing, which is in system dot is an output stream, I think. You know what? I'm just going to go into java.lang again. I need to learn my alphabet. All right, there we go. We're going to go to the system class. Now, real quick, before I even click on system class, system.out. What is out? What kind of animal is that? I'm not asking you what does it do. What is it? Cat, dog, class, method, variable, dinosaur. Why is it a variable?
I'm guessing. I just wanted to say guess, and you were like, exactly, you didn't answer right.
You did get it right.
Oh.
Technically, the more appropriate term for it would be what?
Is it because it's blue?
What would the more appropriate term for this be? What are variables called if they are owned by an object? They're called fields. Fields. So the appropriate term for this would be a field. But at the end of the day, it's just a variable. How do you know that's a variable, Pebbles?
Because every time you ask what is it, it usually turns out to be a variable.
How do you know this guy's a variable, but this guy's a method? There's a distinct difference between those two things I highlighted.
Because in println you can enter something inside.
One has parameters, one doesn't. This one has opening and closing parentheses. This one does not. Only methods have parentheses, have parameter lists. They don't have to take something as a parameter, depends who wrote it, but they still will have an empty parameter list. This guy must be a field. What kind of field? Class field or instance field? Then you're going to guess, I'm going to say, how do you know? So I want you to actually look at this and tell me why it's the one you're going to say. Man, that just gives you all sorts of stuff there.
what was the question?
Is out a class field or an instance field? And then my follow-up question will be, how do you know?
Class. No. No, instance. Class.
Okay, it's a class. So how do you know? I know it's a class field. Where will I find static? You're right, static's involved here, but where will I find the static? Answer it! Answer the question! Anybody? How do I know this is a class field? Calling it using a class name. We know system's a class name, probably because it's capitalized. So, but if we go and look at the system class, we expect to find a field in there with static before it. That's why we are required to call it by saying system.out. So if I go to the, where am I at here? Java.lang. We'll go to the system class right here. Before we click on this, we expect to find a field in there, static, something out. I believe it's a print stream.
Yeah.
Print stream, and it's static, and it's under fields. See how that works? All right, so print stream, so that we're getting back to answering your question now. Print stream is the dude who has the println method. How do we know that? Because we call it using system.out, println. So if I click on print stream, we're going to see that we have a println method in here. In fact, we have a whole bunch of them. What's it called when we have more than one method with the same name but a different number and or types of parameters? Polymorphism. All right, so we see we have a whole bunch of prints and a whole bunch of printlns down here. And we're going to notice that we have a println for booleans, a println for chars, a println for a whole bunch of crap. And then we have printlns for objects. This is our catch-all. If you pass it something that's not a string, that's not a long, that's not an int, that's not a float, that's not a double, that's not any of those other things, you pass me something that's an object, I have to write this generically. What are all objects guaranteed to have? They're guaranteed to have a toString method, because we looked at the object class. So the println version of the print stream class that takes an object as a parameter calls that object's toString method because it's guaranteed to have one. So if we decide to redefine that toString method, give ourselves a more local copy of it in our, in this case, var def statement, then we get something other than just a generic memory address. Make sense? For homework, write this such that it rebuilds the string version of the original statement. You may not just use the stored string variable that I think we called what? The statement? I think we called it that. You have to build it. It's like, this is what you gave me to begin with. I parsed it, but I just happened to hold on to this dude. Okay, we're proving that our syntax tree worked. Make sense? All right, I'll put this up on GitHub and put the assignment up on Angel. This should not be difficult. This should be just as easy as the assignment we had for today. Okay, but I'm forcing you to conceptually think about what we built. Probably a total of
7 hours.
3 or 4 lines of code. But keep in mind that several of those guys might get called multiple times.
Sorry about that. No, you're fine.
Make sense? All right. I'll see you, what day is today? Thursday? See you all on Tuesday.
I forgot a couple lines.